The western region of the United States is well known for majestic mountains, dry deserts, and expansive vistas. Geologic forces have been at work here for millions of years, and earthquakes play an important part in shaping the landscape into what we love about the West today. In this video, we will take a closer look at how earthquake activity impacts the Intermountain West region, particularly urban areas near the Wasatch Fault. Although most earthquakes occur near plate boundaries, there is an area of increased earthquake activity within the interior of the North American plate, known as the Intermountain Seismic Belt. The belt extends 800 miles from Montana to Nevada and Arizona. The Wasatch Fault lies within the Intermountain Seismic Belt and is in the transition zone between the relatively thin and extending crust of the Basin and Range Province to the west and the thicker, more stable crust of the Rocky Mountains and Colorado Plateau to the east. The 240-mile-long Wasatch Fault has the dubious distinction of being one of the longest and most active normal faults in the world. A normal fault results from crustal stretching and is characterized by predominantly vertical movement where the mountain block, Wasatch Range, moves upward relative to the downward moving valley block. Although no large earthquakes have occurred on the Wasatch Fault since pioneer settlement in Utah, the geologic record shows that numerous large surface faulting earthquakes have taken place on the Wasatch Fault over the past 10,000 years. The fault is sectioned into 10 segments. The Malad City segment in Idaho, the Clarkston Mountain segment seen here crossing the Utah-Idaho border, the Collinston segment, the Brigham City segment, the Weber segment, the Salt Lake City segment, the Provo segment, the Nephi segment, the Levan segment, and finally the Fayette segment in central Utah. These 10 segments average 25 miles in length. Each segment can rupture independently and is a separate source of large earthquakes. Approximately 1.6 million people, about 80% of Utah's residents, live along the Wasatch Front, which coincides with the Wasatch Fault, the western base of the Wasatch Range. These cities and communities' close proximity to a large active fault contributes to the Wasatch Front's designation as having the greatest earthquake risk in the interior of the western United States. The largest earthquake expected along the Wasatch Fault is about a magnitude 7.5. The amount of fault movement that produces large earthquakes, magnitude 6.5 to 7.5, is enough to rupture and offset the ground surface. The 5 central segments of the Wasatch Fault present the greatest risk for people living along the Wasatch Front: the Brigham City segment, the Weber segment, the Salt Lake City segment, Provo segment, and the Nephi segment. The composite recurrence interval, or how often a large earthquake has occurred on the central portion of the Wasatch Fault, is approximately once every 300 to 400 years. The 2 last large earthquakes happened about 500 years ago on the Weber and Nephi segments. This is why you may have heard earthquake experts or news reports say that the Wasatch Front is overdue for a large earthquake. For any individual segment of the central portion of the fault, the average recurrence interval is longer, about every 1,200 to 2,600 years. Let's continue our tour of the Salt Lake City segment, starting at the south end of the Salt Lake Valley. The southern extent of the Salt Lake City segment terminates at the Corner Canyon area near the city of Draper. As you follow the fault north, many signs of the past earthquake activity are visible to expert and novice alike. Typically, the fault is easily recognized as a steep, almost continuous escarpment along the base of the Wasatch Range. This escarpment, or fault scarp, forms when large earthquakes rupture and offset the ground surface. Prehistoric earthquakes on the Wasatch Fault have typically displaced the ground surface about 6 to 10 feet for 20 to 40 miles. Here at the mouth of Little Cottonwood Canyon, many earthquake features like scarps and grabens are visible. In May 2008, the G.K. Gilbert Geologic View Park was dedicated. This park at the intersection of Wasatch Boulevard and 9800 South highlights many of these features with interpretive signs and spectacular panoramic views. Multiple fault scarps cut across 16,000 to 18,000-year-old glacial moraines at the mouths of Little Cottonwood and Bells Canyons. Lower Bells Canyon Reservoir, now drained, was situated on land lowered between two fault scarps. This low spot is called a graben. The fault scarps in this area are 100 to 130 feet high, indicating they were formed by as many as 7 to 10 large earthquakes in the past 18,000 years. Sand and gravel deposited as a delta into Lake Bonneville about 14,500 to 16,000 years ago by Little Cottonwood Creek are displaced by the Wasatch Fault. Now a water filtration plant sits on this ancient delta. High fault scarps indicate several large earthquakes have taken place here over the past 14,500 to 16,000 years. The other arrows show the fault zone branching into 3 strands in subdivisions adjacent to the Wasatch Boulevard in Salt Lake County. Visible scarps are not continuous along the fault. They disappear at segment boundaries and in areas where natural erosion, deposition, or construction has obscured them. In most places, the Wasatch Fault is at the base of the mountains. In other areas, the fault extends away from the mountains, such as in the Holiday area, where Highland Drive parallels part of the fault. In addition to ground shaking and surface fault rupture, earthquakes can generate other geologic hazards that include soil liquefaction, slope failure, and flooding. Not only are buildings, including homes, endangered by these hazards, but water tanks, dams, roads, bridges, railways, airports, and utility corridors carrying electricity, water, sewage, natural gas, petroleum, and telephone service are all at risk. Along the Wasatch Front, many of these structures and utility lines are located on or cross the Wasatch Fault. Although development, and in some cases unsafe development, has encroached on the Wasatch Fault, some areas have more compatible land uses with an active fault, such as tree farms, golf courses, and parks. For example, Fault Line Park, located at 400 South between 10th and 13th East in Salt Lake City, sits on the Wasatch Fault Scarp. Because Utah has not experienced a large, damaging earthquake in the heavily urbanized Wasatch Front since the pioneers entered the area, many older, vulnerable buildings place people at risk. The state of Utah has retrofitted the state capitol building in a way that preserves this historic building and ensures the public safety and continuity of government in the event of a large earthquake. Improved building codes are in force statewide. Some older buildings have been strengthened, and steps are underway to upgrade schools and other critical facilities. Utah's Wasatch Front is a desirable place to live, but choosing to live here includes accepting earthquake risk. Earthquakes are part of the earth that we live on, so while we can't change the fault, we can learn to live with it. Natural hazards are present in all regions of the U.S. Therefore, it is prudent to be aware of what we can do to lessen the risk of damage and injury from natural disasters wherever we live. And awareness is the first step in risk reduction. For more information about earthquakes, how you can prepare for them and other geologic hazards in Utah, visit our website at geology.utah.gov or visit the Utah Department of Natural Resources bookstore to find other materials and information.